Hello class! Today we are going to learn about circuits and currents, more specifically series and parallel circuits, and then AC and DC currents. But before we can get into all of the confusing electricity things about circuits and currents, we first must understand electricity. So, what is electricity? We have it all around us. We are very dependent upon electricity. But how do we even define electricity? So we first must look at the atom. And if you remember from chemistry, we can see the atom is composed of a nucleus that contains protons, which are positively charged, and neutrons, which are neutral, so no charge. And then they are surrounded by a cloud of electrons, which are negatively charged. So how do these atoms help us understand electricity? Well, as you've probably heard, opposites attract and like charges repel. So we have a positive and a negative charge, and they will attract to each other. But if we have a positive and a positive, they're going to repel, or a negative and a negative will also repel. And how does that help us understand electricity? Well, looking at the atom, we know that the protons are going to repel each other but be attracted to electrons. Likewise, electrons will repel each other but be attracted to protons. And if we look at these atoms here in a row, and we remember from chemistry, electrons can be exchanged between atoms because they might be in close contact to other atoms and be attracted to other atoms' protons. So electrons in a, let's say, copper wire can move from one copper atom to another copper atom to another copper atom to form this sequence of electrons moving through the copper wire, which we will call a conductor because it's a metal. So with this chain of electrons moving from atom to atom to atom, this creates an electron flow, or what we can also call our electric current. This electric current is what supplies us with the electricity that we have all around us, and that allows us to charge our gadgets and gizmos like cell phones or Game Boys, which you all don't really play anymore, or our TVs, our ovens. All of our electrical appliances depend on electric current. Now, there's two types of electricity. The kind that I was just describing is called current, electric current, which means it's constantly moving or flowing. But we also have static electricity, which you guys have probably heard of whenever you shuffle around on your feet on a carpet and then you poke somebody and it shocks them because there's a built-up static electricity. That means there are electrons or energy stored and at rest until they are probed through that poking that will release the electrons. But we will mainly be focusing on current electricity, and that's what you will see demonstrated through circuits. But what is a circuit? A circuit is a closed loop through which electric currents can flow. So if we just think of the definition of a circuit that we think of just in like an English class, you can run circuits, which would just be like laps around a track or something. So speaking at the physics mindset, a circuit is just a closed loop, so like this makes a closed loop, but electric currents flow through it. So circuits will typically be composed of conducting material so that electric current can flow through it. And there are two types of circuits, series and parallel. Well, there's more types, but these are the two we're going to focus on. So a series circuit looks like this, but what does that mean? It's a closed circuit, and it has a battery charging it, and the flow of electricity will flow from the positive end of the battery through these resistors and back to the negative end. The circuit is described as a series because there are two components in the series that share a common node. And a node is just the electrical junction between two or more components. So the green parts, the green lines, would be considered our nodes. So there are two components, there's actually three resistors here, and a battery, and they share common nodes. And electric current is flowing through each of them. The same electric current is flowing through each of them. Now this looks different in a parallel circuit because there's our parallel circuit. A parallel circuit is defined as components sharing two common nodes will make it a parallel circuit. So if we look at our battery and our resistors 1, 2, and 3, they are sharing more than one common node, more than one green part. To demonstrate the difference between series and parallel circuits, I will create examples of different circuits that you can classify as parallel or series. So we have just a common battery that you can put into a fan or whatever else that runs on batteries, and plug it into light bulbs to see if your nodes can turn the light bulb on. So I'll first, let's say, move a light bulb over here, and the second light bulb over here, and take my red wire, plug it into the negative side of the battery, and plug it in here. The colors don't have to match up for this simulation. And then let's just connect this light bulb to this light bulb. And then I won't use all of my wires just yet, and let's see what happens. Our light bulbs turn on. Now this could either be a series or parallel circuit. You all must tell me. I'll make another circuit that you can classify as parallel or series. So I'll move these two light bulbs like this, plug in my wires, light bulb 2 lit up. Let's see if I can light up light bulb 1. There we go. Now would this be a series or a parallel circuit? You tell me. In class we will practice these circuits and get more information about electricity. The end.